So on your worksheet, the angles are already there. So your angles, we have 30 degrees, 45. Thank you very much. 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. So those degrees are already on your circle, okay? So let's go over some strategies for filling in the radians, okay? I know I sound like a broken record, but you must know this unit circle. You absolutely must know it, okay? And you must know your radians. Now, the tendency, I understand, I do it too, but the tendency is to revert back to degrees, right? But we have to know our radians. We have to be able to say, oh, the sine of pi over 6 is 1/2. Okay? We have to be able to say the sine of 4 pi over 3 is the square root of 3 over 2. We have to be able to do it like that, okay, without converting it to degrees. Please trust me, because you never know when you might have a quiz on the unit circle. You just never know when you might have a quiz on the unit circle. Okay? You must know this. So there's a couple strategies for filling in your unit circle. The first thing I do is I go through and I fill in all of my 45-degree angles. I'm just going to shrink this down so we can see the whole circle. Okay. I fill in all of my 45-degree angles. Every 45 degrees, Gabrielle, is how much? What's every 45 degrees? Pi over 4. Every 45 degrees is pi over 4. So here's my pi over 4. Another 45 degrees brings me to 90. So this is 2 pi over 4. I'll go back and reduce later. And then the next 45 degrees, we have 3 pi over 4. And what I do, just to make it a little easier for myself, is notice how I wrote the 2 pi over 4 like kind of on the other side of the 90, right? This is my final answer. I'm going to put my final answer closer to the actual circle, okay? All right, so that's 3 pi over 4. And then 45 degrees, we have 4 pi over 4. 45 degrees, 5 pi over 4. 45 degrees, 6 pi over 4. 45 degrees, 7 pi over 4. 45 degrees, 8 pi over 4. So I go around, I do all my pi over 4s. Notice I did not have to use a formula to convert the 45 degrees to pi over 4. Right? I just know that. So now I'm going to go back and I'm going to reduce. So this reduces to pi over 2. Okay. This one reduces to pi. This one reduces to 3 pi over 2. And this reduces to 2 pi. Oops, I should have written that here, I guess. Messed up my system. Okay. So this is 360 degrees and 2 pi. Okay, this is 0 degrees and 0 pi. So I'm going to erase the ones that are in the inside because I've reduced them. Okay. All right, I have all my pi over 4s. The next one I'm going to do is the 30-degree angles. So 30 degrees, how many pi units is that? Pi over 6. Okay. So every 30 degrees, I add another pi over 6. So we have 2 pi over 6, which reduces to pi over 3. We have 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Every 30 degrees, we add another pi over 6. So now we're ready to go through and reduce. Okay, so let's see, pi over 6, 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 is fine. 6 pi over 6 reduces to pi. 7 pi over 6, we're fine. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And then we have 11 pi over 6. We're going to go ahead and erase the unreduced ones on the inside. And we are finished with our angles. Okay, question on how we did that? It's really easy. Okay, you should be able to do it quickly. Okay. All right, let's look at the coordinates. So again, I'm going to go around and I'm going to do my pi over 4s, my 45-degree angles, because the 45-degree angles have the same x and y. Square root of 2 over 2. All of the 45-degree angles, I'm excluding anything on an axis. We'll come back and do the axis later. So here's the next 45-degree angle. So root 2 over 2. But in this case, because we're in the second quadrant, the x is negative. And then down here, root 2 over 2. And here they are both negative. And then in the fourth quadrant, root 2 over 2. And the y is negative. Okay, so all of those pi over 4 angles, we have the same x and y value. We good with that? Okay, so all of the pi over 6 or 30-degree angles, right? I'm choosing between root 3 over 2 and 1/2. And the way I make that decision is by envisioning that triangle. Okay, we're just going to envision the triangle. And then I look at the x and the y. Okay, so on 30 degrees, the x value is longer. This is longer than the y value. That means the x has to be the square root of 3 over 2, and the y has to be the 1/2. So that's how I decide which is which side is longer. So when we look at the 60 degrees, which side is longer, the x or the y? Diana, which side is longer, x or y? Okay, look at this triangle. 60 degrees. Which side's longer, the x or the y? The y. So that means y is square root of 3 over 2, and x is 1/2. Okay? And we're going to go around the triangle, and we're going to fill in those coordinates. Okay, so looking at 120, this is another triangle where the y is longer. So the y is root 3 over 2, and the x is 1/2. One of them's negative. Which one's negative? The x. The x is negative. Okay. 5 pi over 6. Caleb. Which side is longer, the x or the y? Yeah, so the x gets root 3 over 2, and the y gets 1/2. And again, the x is negative. Okay. Alex, 7 pi over 6. Which side is longer, x or y? X. So x is root 3 over 2, y is 1/2, and here they're both negative. Isabella, 4 pi over 3, which side is longer, x or y? Y. So the y is going to be root 3 over 2, and the x is 1/2, and they're both negative. Okay, Ariel, what's the coordinate for 5 pi over 3? Good. The x is shorter, so it'll be 1/2, and then negative root 3 over 2. The y is negative. And then the last one, we've got root 3 over 2, negative 1/2. Okay, so all we have to do is envision the triangle and figure out which side is longer and which side is shorter. Okay, let's go back in now and label our axis. So we've got 1, 0 here. This point up here is 0, 1. And over here at pi, it's negative 1, 0. And at 3 pi over 2, we're looking at 0, negative 1. And our unit circle is complete. You need to make sure you know how to do this because you never know when you're going to have a pop quiz on the unit circle. Okay. Okay. Your homework. Does everyone have that down? Am I okay to move to another page? All right. Your homework was 4, and I gave you 9 through 14, and then 23 through 26. Okay, now these took a little bit of work, all right? So first off, yes, these can be done on your calculator. But if it says exact value, then you're not going to use your calculator because exact value, if you do square root of 3 over 2 on your calculator, whoops, let's try that again. Divided by 2. Okay, we get 0.866, right? So if let me make sure I'm in degree mode. If I do cosine of 60 degrees, what do you think we're going to get? Cosine is 60. Picture your circle. Where's the 60 degrees? Right? Picture your circle. Where's the 60 degrees? Up here. Which one's longer, the x or the y? The y is longer, right? And this is what I do. Okay? If I don't know the value right off the top of my head, I just make a little sketch. I'm asking for the cosine of 60, right? Here's my 60 degrees up here. That's enough for me to envision my triangle. From this, I can tell you, oh, the x is shorter and the y is longer. So that's my coordinate. So the cosine of 60 degrees, what will that be? 1/2. Cosine of 60 degrees is 1/2. Well, that's fine if you do that on your calculator because that is an exact value. But if I do the sine of 60 degrees, that's going to be the square root of 3 over 2, which gives us a rounded answer. Okay? So if we're asked for the exact value, that's the hint that we're supposed to be using our unit circle and not the calculator. Okay? Okay. So we've got the cosine of 60 degrees, which we just figured out was 1/2, and the tangent of 45. Well, what's the tangent of 45? 1. Yes, 1. Okay, just a reminder, okay, because it feels like it's been a while. When we talk about the cosine of an angle on the unit circle, that's the x value of the coordinate. The sine of the unit circle is y. The tangent is y over x. Okay? All right, so this is going to equal 1.5 or 1.5. Okay? Okay, sine of 30 degrees. What's the sine of 30 degrees? Right? Here's my 30 degrees. Which side is longer? The x is longer, so that means the y is shorter. Sine is y, so what's the sine of 30 degrees? 1/2. What's the cosine of 45 degrees? Caitlin, what's the cosine of 45 degrees? Yeah, square root of 2 over 2. So we're just going to write this as 1 minus root 2 over 2, and we're done. Okay. Okay, number 11 gets tricky because these are reciprocal functions. All right, the cotangent of 45. Morgan, what's the cotangent of 45? 1. Yeah, it's the reciprocal of tangent, but that's just 1. All right, so we've got 1. Okay, now to figure out the secant of 30 degrees, I want to figure out the cosine of 30. Now, to be honest, some people will memorize the formulas for these. I don't. I just figure out its reciprocal and flip it. Okay? So the cosine is x. And at 30 degrees, Jesse, what's the cosine of 30? Root 3 over 2. Root 3 over 2 is a cosine of 30, right? Okay? So that means the secant of 30 is 2 over root 3. So we have to rationalize the denominator. So we move and remove. There we go. 2 root 3 over 3. Okay? All right, tangent of 60. Now we're getting a little harder. I hate the tangents. Tangents are a pain in the neck, right? Okay, so what's the coordinate at 60 degrees? Alex, what's the coordinate at 60 degrees? Yeah, 1/2 root 3 over 2. That's the coordinate at 60 degrees. Well, tangent is y over x, so that's root 3 over 2 over 1/2. Okay, which means I've got root 3 over 2 times 2 over 1, which equals root 3. Okay, that's the tangent of 60, square root of 3. Now we've got to do the cosecant of 45. So I've got to figure out the sine of 45. Okay, Jordan, what's the sine of 45? Good, square root of 2 over 2. So that means a cosecant of 45 is 2 over the square root of 2. We've got to move and remove. So 2 root 2 over 2. So they cancel. So we're looking at the square root of 2. Multiplying them together, I get the square root of 6. Okay. I can check this on my calculator. Right? Let's see. Tangent of 60 times, now I had cosecant, so it's going to be 1 divided by sine of 60. All right. Uh-oh, what'd I do? Oh, it was 45, not 60. 45. 45, try that. Okay, let's see if that's the same thing as the square root of 6. And it is. So that's how we check it on our calculator, okay? Okay, any questions for me on these problems? Really? You guys all get it, or are you all asleep? No, pre-cal first period is tough. Kevin. Okay, let's move down. Find these 6 exact values. I'm not going to go through all of these. However, it's talking about places where it's undefined, right? So when would it be undefined? When the denominator is 0, right? So if we're talking about sine, cosine, tangent, cosecant, secant, and cotangent, all right? Now, sine is the y, cosine is the x. So sine and cosine are not going to be undefined. Even if it's zero, zero is okay. That's not undefined. Tangent has a potential place where it's undefined. Tangent is going to be undefined anytime the x value is 0. Well, where is the x 0? Here and here. So tangent will be undefined at 90 degrees, or pi over 2, and at 270 degrees, which is 3 pi over 2. Tangent will be undefined in those places. Okay? Where will cotangent be undefined? When the y is equal to 0. When's the y equal to 0? At the x-axis, which is 0 degrees, or 360 degrees, and 180 degrees. Everybody following that? Okay, how about cosecant? When will that be undefined? Cosecant is a reciprocal of sine, so it's 1 over y. So that's going to be undefined in the same spots. Cosecant will be undefined in the same places. Secant is 1 over x, so it's undefined up here at 90 and 270. Okay? Okay, let's look at number 24. 7 pi over 3. Well, that's not one of the angles that we learned on our unit circle. How do I find 7 pi over 3? Jackie, how do I find 7 pi over 3 on my unit circle? Okay, if I start right here, okay, and I go all the way over to the other side, right? How many pi's is that? 1 pi, which is equivalent to 3 pi over 3, okay? Now, if I go all the way around the circle, how many pi's is that? 2 pi, which is 6 pi over 3. So I have to go another pi over 3, 6 pi over 3. And where's that other pi over 3? Well, this is pi over 6, so pi over 3 is right here, which is, that's my 60-degree angle, right? This is pi over 3. So 7 pi over 3 is the same thing as pi over 3. It's the same location. Okay. Now, some people prefer to just count it going around, right? Here's pi over 1, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. Okay. Another way of doing it, and again, this is all a matter of preference. Since you learned to make your unit circle using pi over 6 and not pi over 3, sometimes it's preferable to convert this denominator to a 6. So that'd be 14 pi over 6. Because you learned to do your unit circle in pi over 6s. So let's do that, right? Here we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6, 14 pi over 6, right there. Okay? So you can do that also. Okay, number 25. Where's that negative 3 pi over 4? So negative, what does that tell us on the unit circle? We're going the other direction. We're going this direction. So we're just going to count again. Here's negative pi over 4. Here's negative 2 pi over 4. And here we have negative 3 pi over 4. Okay. Okay. Questions for me? Okay, I have a worksheet for you to do. This is due this period. This is not homework, it's due this period. Okay. When you finish, you can start on your homework. Oh, wait, I have to go over something with you. I'm sorry. Well, let me have you do this worksheet first, and then I'll go over the other thing with you. Okay. You can use your unit circle to refer to. Save you some time. And I need to see everybody doing their own work. When we were doing that unit circle, I saw a lot of wandering eyes. Right? Lack of understanding is not an excuse for wandering eyes. Mm-hmm. Okay. There you go. Good down. Okay. Did you miss all last week? Oh, okay. You didn't miss the introduction.
No, but I used to for that.
Okay. I'm going to catch up.